Hello guys. So yesterday we are discussing about the ultrasonic sensor. I think you people are understood very well. So today I will show my output in live. Okay. So already I am connected the circuit of using 4-line C. This is what I'm writing the yesterday code, but I am taking the extra distance also. Okay, I am taking the extra LEDs also. That thing I'm changed here. Okay, remaining every code will be same. You can check this one. Remaining every code will be same. Everything. So now as it is as per process. So I'm running the code. Click on. So this is our code, and you can connect the pins as per our bit string. Sir, where you are connected the pins, sir? How can we connect the ultrasonic sensor? How can we connect an external peripheral? How is it possible, sir? Simple. See, now I am using the Edge board, Edge RTX 7 FPGA board. You people are know it very well, all of you. Now I am using this board. See this one. See, this board has a extra P mode is there. See here, the camera is connected here. Okay, the camera is connected here. I will show the image. Edge RTX 7 FPGA board. Yeah, this one. So I think this is visible to you. All of you, please see this one. So there is an extra P mode to connect the external peripherals. Okay, to connect the external peripherals. So all of you, please see this one. How I'm connected. So the clock is I'm connected to the N11 pin. That is common. See, the clock is I'm connected to the N11 pin. See here, I'm connected to the N11 pin. Of course, for echo and trigger. And these LEDs, I'm using these FPGA LEDs. See, I'm using this T9, T10, R5, T5, R6, R7, and P6. See this one. T9, T10, R5, T5, R6, and R7, P5, and K5. See, up to here, I'm using these LEDs. And of course, for T12 and P11, these are, we need to connect. If you want to connect any kind of sensor to this FPGA board, you have to use this kind of P mode. Okay, you have to. So I'm using this P mode for external connections. See, you need to connect the sensor voltage here and ground here. If it is any sensor, you can connect. If you want to use the 5 voltage, then you can connect the wire to 5 voltage. Otherwise, you can connect your wire to 3 voltage. Okay, and these are our data pins. See, I'm connected my echo pin to T12. See, I'm connected my echo pin to T12. Okay, all of you, I will write and show it. See, T12 is my echo pin. See, this is my FPGA side. Okay, and this is my sensor. This is my sensor side. All of you. In FPGA, I'm connected echo to my T12. And of course, trigger to my P11. P11 to my trigger. And of course, VCC to VCC. VCC to VCC to VCC. And of course, ground to ground. Sorry. Ground to ground. Okay, see, these are the 4 sensor pins. I am connected, how I am connected to the FPGA. Okay, so these 2 external pins I am using the jumper wires to connect the sensor. Okay, now we need to come the code. See, this T12 and P11. And of course, these are LV CMOS 33s. We are connected to the input output standard. So I will show my output. Can click it on the program and see, click it on the open target, just a minute. Program and program device. Now, yeah. So now you can click it on program. So now the FPGA is successfully dumped on my FPGA board. I will show the output. Okay, no, you no need to worry about it. So I will off my screen share. I will share my cam footage. Yeah, I think my cam is visible to you all. See this one. So now I'm using this. I'm connected in this P mode here. See, I'm connected the T12, and of course these pins are not. I mean, these pins are in this cam. It is not visible. So I'm connected to the T12 and P11. Of course, these are ground and VCC. You can check the image also. Okay, you can check the edge board image. That is also possible. See, now it will calculate the up to 40 centimeter distance. See, if I'm comes, I mean, if I'm come to this one, the LEDs will be off. See, one by one, the LEDs will be on here. See, the distance is longer, then the all LEDs will be on. This is up to 40 centimeters. Okay, the cam wire is there. Of course, it will be calculated. I mean, from few LEDs are blinking because of the cam wire is there. Okay, there it will be detecting the distance of this cam wire. Okay, and you can observe this one very carefully. If it is shorter distance, all LEDs will be off. See, 10 centimeters. Of course, 20, 30, 40, 50, 60, 70, up to you can. It will be up to 400 centimeters. You can calculate any kind of distance. Okay, so this is the total information of ultrasonic sensor. Okay, all of you, and this is the implementation. Yeah. So I think you people are understood. If you have anyone have any doubts, you can ask me. I will clarify it in here. See, how can I connect the board, and how can I see? I'm using this normal jumper wires. With 4 jumper wires, I'm connecting the board. Okay, I'm connecting. I'm using this jumper wires. See, only 4. Sorry, only 4 boards. Only 4 ground and VCC. Of course, trigger and this echo. Okay, so these I'm using here. Okay, yeah. So this is the total information about the ultrasonic sensor. Yeah, I will share my screen. Already I was sent the code here. Already I was sent the code of ultrasonic sensor and LCD also. Okay, I was already sent. I mean, I think tomorrow or definitely you will receive this code. Okay. See, sir, how is it possible of multiple distances? See this one. I am changing the little bit of code here. See, I'm changing. I'm writing the changing the distance code. Okay. For if it detect the 40, some LED 6 will be on, LED 5 will be on, LED 4 will be on. Now, if you can change, if you want the particular LED, definitely you can give this kind of distance. Okay, this is my previous one, all of you, and of course the code is same. There is no change in the code. The code will be same. Only I'm writing the extra code for this LEDs. That's it, all of you. Yeah. So this is the total information about the ultrasonic sensor. So today we are discussing about the servo motor. Okay, all of you. As per this process, today we are discussing about the servo motor. I think we have to follow the same steps with servo motor also. So what is the servo motor? See, the servo motor means I will show it. I will show the image. I think I'll show the image. See this one. So yeah, this one. Servo motor. Okay. I think it will. I mean, it will be. I mean, we are using some kind of application for this servo motor for like using this for angles. I mean, it will be moving the like few kind of applications. Now, just a minute. We are discussing about the few points about the sensor. Okay, no need to worry about it. So after this servo motor, we are discussing about the LN28 DC motor. I mean, motor drive also. Okay, all of you. LN28 motor is there. I mean, motor drive. We have to discussing about that after this servo motor. Okay, yeah. So all of you please see this one. What is the servo motor? What is a servo motor? See, what is a servo motor? Of course, you need to know. about the few basic information about this servo motor. So this servo motor has internally they have a potentiometer and control circuit and gearbox. I mean DC motor of course is there. See this, I mean a servo motor, it's a precision motor. Okay, you need to understand it's a precision motor, all of you, with that can rotate the specific angles only. See, it will be rotate the motor. It will rotate the motor. It will rotate motor and object. I mean, to specific angles. To specific angles only, or distance, or whatever it may be. Okay, as per choice of due to the servo mechanism. All of you. The I mean, see, we are using this PWM function for this servo motor. Okay, we are using the PWM function bit for this servo motor. Sorry, yeah. No, I'm closing this one. Yeah, thank you. This one. Yeah, sorry for this. Sorry for the delay. Yeah. See, the servo motor was working by the servo motor was working with 50 Hz frequency. 50 Hz means nearly 20 milliseconds. Okay, 20 millisecond period. The servo motor was working with this speed. Okay, 20 millisecond speed. And it will rotate on the specific angle as per our frequency. See, as per our the clock pulses. See, I'm explaining with a technical terminology as per my related to my FPGA board. Okay, to specific angles, as per our choice. Okay. See, internally in the servo motor there is a precision. Internally in the servo motor there is a precision motor is there. Okay, a precision motor is to of a closed feedback control. There is no main point here. Yeah, so I will explain about this main one. See, so one pin is there. Okay, so they have 3 pins. Of course, one is PWM. I mean, of course, I will draw the exact diagram. What do you understand? I'll draw the exact diagram. See, and I think yeah. So this top angle is correct for that image. Yeah. So this is the orange color. See, you need to recognize the colors. They have 3 wires. One is orange color. Of course, red VCC is the red color. And of course, brown is the ground. They in the servo motor, they did not mention that. This is the brown is the ground. And of course, VCC, there is VCC in red color. And of course, orange is the PWM. Okay, orange is in PWM. Okay, all of you. This color coding is, of course, it is very, very important for the servo motor recognition. So this is the main data pin. Of course, this is for the power. Okay, this is the main data pin to decide the angle. Okay, see in the servo motor, if it is in 0 and I want to change it in for the 90 degrees, and of course it will be available for the 180 degrees also. Okay, we will take this is the 180 and this is the 0. Okay, see it will change 90 and 180 also. Okay, yeah. See, suppose, sir, now I want 0 to 90 degrees. How it is possible, sir? Now I want 0 to 90 degrees. So how can I do that? In FPGA to connect the servo motor, I want 0 to 90 degrees, sir. So as per my application, how can I do that? See, our PWM period is 20 milliseconds. That means 50 Hz of my PWM period. Of course, I'm already told that. I mean, I'm already told that 50 Hz. Okay, servo motor speed. 50 Hz means 20 milliseconds. That means if you want, for the 0th position, the you know what is the pulse width? 1.0 millisecond. The one for the 1.0, the GT is represent the servo rotates. Servo, of course, servo rotates to 0 degree position. 0 degree position. Just it will give a little bit movement is. That's it. Now it is 0 degrees. Okay. So no, sir, we want the 90. I want the 90 degrees, sir. How can I do that? I want the 90 degrees. So if you want the 90 degrees, see, you have to convert this 1 milliseconds to 1.5 milliseconds. 1.5 millisecond pulse width. Okay. Then the servo moves to the servo rotates or moves to the 90 degrees position. The servo moves to the 90 degrees position. Okay, sir, no, sir, I don't want the 90 also. I want the 180. Of course, it is definitely we can give the, I mean, if you can give as per inputs, definitely it will move to the specific angles. If you want the 180 degrees, definitely you can write the code 2.0 milliseconds. So this is the pulse width. So the servo moves to the 90 degrees position. Sorry, 180 degrees position. Okay. So these are our three specific angles in this servo motor. Okay, all of you. And of course, the servo motor is controlling through the PWM pulse width modulation signals. Okay. For except control pulse for every 20 milliseconds. A control pulse is there for every 20 milliseconds. The pulse width we can determine the rotation angle. Okay. And of course, I will show it. I will draw the what we can call it as. I will clearly draw this one. See this situation. I will clearly draw this situation. See, suppose this is my 0 degrees. See, this is my 0 degrees. This is my 20 milliseconds. That means 50 kilohertz time. See, sorry, 50 hertz time. This is my 50 hertz in the sense 20 milliseconds. Okay. So for 0 degrees, this is the time for the 0 degrees. See, for only I want starting 0 means it is starting point. Okay, don't give this kind of distance. What happened to this one? Starting point. Yeah, here. So this 1 millisecond. See this one. This 1 millisecond. In this whole 20 milliseconds, I want only 1 millisecond for 0 degrees. If you want the 0 degrees, this if you can change the angle, if you can change the angle into the only 1 milliseconds. If I want the time for 1 milliseconds, okay. If you want it to 90 degrees, just you can take extra time. See, just 1.5 is enough. Or you can take the similar one. Okay, you can take more than 1.5, no problem. You can take the more than 1.5. Of course, if you want the 180 degrees, sorry, yeah. Now it is 2 milliseconds. So this is the overall pulse width modulation. Okay, this is the overall pulse width modulation. This is for 180 degrees, and this is for 90 degrees, and this is for 0 degrees. Okay, for the angular. Yeah, of course, this is the multi-axis control. And sir, now, sir, suppose if you want the 45 degrees, sir, what I do? Suppose I want the 45 degrees. So now what I do, sir, simply between you have to take the, I will explain it in code because of, you can take the 1.25 milliseconds something. Of course, you can take in the middle of this one. Of course, in the code also, I will explain this one. Okay, many more theories there according to our code. Okay. Yeah, all of you. So this is the total information of our servo motor. Okay. So now I need to explain the little bit working principle. Of course, these are the key feature. See, if you use this kind of, there is a servo motors like SG90, everything you can control, and M6, MG995. So this code is available. This code is eligible for. I mean, see what I have to explain in this code. Definitely, that is eligible for both servo motors. Okay. Of course, you have to use this popularly for applications. The servo motors are widely we have used in the robotic projects, for home automation projects and RC vehicles. Of course, it is very useful. Okay. Yeah. So now coming to this one, we will move on directly. I will explain the code. Okay. Yeah, the code is a very small one. I will close this one. So this is the previous one. Okay, leave it. Yeah. Servo motor. Only 4 inputs is there. Only 4 inputs to the servo motor. Okay. See, according to our servo motor, see, this is the FPGA. You can use the same connection. See, of course, this is my FPGA board. Already you have seen that. Okay. So you can use the same kind of PMOD. Same kind of PMOD for this is the here VCC. You can connect the VCC. Of course, 3.3 V voltage here. So I will show it the board. Okay, I will show it in the board. I'll show it in the board. See 3.3 volt. This is we have to use this kind of with this PMOD. This 3.3 voltage. You can connect this because of parallel handling. Okay. Yeah. So now I'm connecting this 3.3 voltage to this VCC. Of course, see this 3.3 voltage. This and of course ground. See ground here, left side ground connected to ground pin, and your PWM pin you need to connect this T12. See this T. I'm connecting to this T12 pin. I'm connecting this T12 pin. Okay, VCC, of course, ground. I mean, if any order is wrong, then no problem. Okay, ground. Of course, the ground is connected here, and VCC, and of course, this one is PWM. Okay, and of course, you need to connect your motor be like this, all of you, and you can give your you can give your angle selection. If you can give any kind of switch for this angle selection, you can use any kind of switch here, any kind of this slide switch. Okay, these slide switch will be defined that the angle selection. If you can give if you can give switch will be off, then that means 0. If your switch will be on, that is meaning is 90. That switch will be decided. See here. That's why we are using this angle selection. Okay, all of you. And of course, this clock reset and angle selection and servo out. These are our input outputs. See, this is our servo out pin or output. And of course, this is my angle selection input. Of course, this is my angle selection. Of course, there is a clock is there. And of course, you can use any kind of this push button for reset. See, all of you observe this one. Clock. See, one push button is for reset. One is for angle selection. Of course, this pin will give the PWM to. I'm using the jumper wire to connect. This is the servo out. Okay, that's it. All of you. So this is the PWM out. Of course, this is the angle selection, clock, and this is for reset. We are using the push button for reset and slide switch for angle selection. And of course, clock pin is common, N11. And of course, this T12 is, we are connected to the jumper wire to the, see, I am assigning the output pin to T12. So now we are connected this jumper wire to connected this external device. Okay. And these are the power wires. So this is the circuit connection, what I am giving the package pins also. Okay. And here you can come. See, these are, of course, you people are understood how I am creating the input outputs. Next, you can come into this local parameter PWM period 1 lakh, pulse 0, 50 lakhs, I mean 50,000. Of course, pulse 90, 75,000. Sir, what is this 110 lakh? Of course, what is these values? We could not understand what is the meaning of these values. I will explain. See, in the previous chapter, we are discussing about the frequency division. You people are know about it very well. Of course, in the previous class for you discussing about the JK flip-flop, I am explaining about the frequency division. Okay. So what is our internal clock frequency? My FPGA board internal clock frequency is 50 megahertz. See, this is my internal frequency. But servo motor, how much I want? For servo motor, how much I want? See, shall we use this frequency? No. For servo motor, I want 50 hertz. That means how much time? 20 microseconds. So 20 milliseconds. Okay. I want 20 milliseconds, but this 50 megahertz is 20 nanoseconds. So we need to increase the time. Okay. That means we need to decrease the frequency. I mean, we need to increase the time and we need to decrease the frequency. We need to division the frequency. I want the 50 hertz for my, see, the servo motor working with 50 hertz. See, in the theory also we are discussing about the servo motor working with 50 hertz frequency. But if you use the 50 megahertz, then the definitely the servo motor will be not work. I mean, the servo motor not fit for this working this much of frequency. The servo motor did not want that. Okay, this much of speed. Okay, so you want to convert our frequency. Simply, you can use your formula. Output frequency is equal to input frequency by number of mod counts. So please do this calculation. If anyone, please do this calculation. I don't have any problem. Please do this calculation. What is my input frequency? Input clock frequency 50 megahertz. How much output frequency I want? 50 hertz. See, 50 hertz, 50 megahertz by number of mod counts. Number of mod counts. I am repeating the theory. Okay, no need to worry about it. Just I am repeating the theory. If anyone forgot it. So the number of mod counts is equal to 50 megahertz by 50 hertz. So, you know, 50 in, I mean, of course, 1 megahertz. 1 megahertz into, that means 1 into 10 power 6. So how many zeros here? 1 into 10 power 6, 3 zeros. I mean, of course, 6 zeros. So this is that 6 zeros. Okay, the PWM period. This is the 20 milliseconds. Okay, this is the count. Okay, we did not give the time directly to the, we did not assign the time. We are assigning only the clock pulses. Okay, the counter, only the counter will be available for here. Okay, the counter time only will be available for here. So here, this answer is I am giving to this one. Okay, so this is the 1 millisecond. Of course, you can use this one. 1 milliseconds. How much of the time? You can convert this. You can convert this one. You can repeat the same process. 1 millisecond. Of course, you know how many edges. I think 10 edges is the like. I mean, I don't know frequently, but of course, same process. You can repeat the same process for the 0 degrees also. For the 0 degrees and 90 degrees, you will get the 75,000. And here you can give get the 1 lakh. I mean, sorry. I'm writing the wrong values. You will get the 50,000. Okay, of course you can here you can get the 75,000. For 180 degrees, you will get the 1 lakh. Okay. See, but here we don't want the 180. I'm doing only 0 to 90 degrees. I want. Okay. Yeah. So 50 clock pulses. See, this 50 clock pulses and 75 clock pulses for 90 degrees. Same, you can repeat this process. You can repeat this process. 50 megahertz, of course. 20. I mean, see, we will calculate the time also. We have number of mod counts is also there. Output frequency. What is 50 megahertz? So how much counts? Of course, we know 50,000. You can do it. 15 to 10 power of 15 to 10 power of 3. Yeah, I think. Yeah. So of course, 15 to 10 power of 6 cancelled. Of course, 1 10 power of 3 is remaining. I think 1,000 edges. 1,000 edges. Of course, I think, I mean, I don't know approximately what calculation, but this is the 1,000 degrees. Okay, you can repeat the same process for this one for 0 and 90. So I'm getting these calculations. Okay, for pulse 0, 50 clock cycle. See, this is for 20 milliseconds. This is for 1 millisecond. Okay, and this is for 1.5 millisecond. Okay, for timings. And of course, the counter. Of course, the counter and pulse width is pulse width. I will explain why this counter and pulse width. Coming to this one. Why I'm taking this counter? See, to calculate this, to count this 1 lakh frequency, of course, this 10 lakh frequency, I want to count this 10 lakh frequency. So that's why I'm taking this counter. Okay. Of course, I want to count this 0 to this, yeah, this kind of much of count. So that's why I want the big counter for this count. Okay. So that's why I'm taking this counter. Okay. Of course, the pulse width also like that. All of you. Same. So if you so the pulse width is per, I mean, this pulse width is per the stored the selected on time. Okay, the stored the selected on time. That's it. Of course, this is the reset signal. So now coming to the next code. This code is very easy. Okay, you need to worry about it. You don't need to worry about it. This is the small code of the pulse. This servo motor. Very small code. Of course, I will detail explain if you carefully listen. If you on the reset, if you once on the reset, definitely what I want according to the servo motor, I want coming to the servo motor to the initial position. That means 0 angle. See, the pulse width, of course, I want to come to the, if you on the reset, definitely I want the pulse width to the pulse 0. I want to come to the 0 pulse 0 angle. Okay. Of course, the servo out means output. The servo out want to become 0. See here. And of course, the counter will be also coming to initial position. Okay, 3. See this one. Pulse width. And of course, servo out and counter. These 3 will be come to initial positions if the reset will be on. If the reset will be off, again it will start the working. See if you can give the straight code and direct code. You can directly give this angle selection. See where the angle selection will becomes, all of you, where the angle selection will becomes. See according to this one. If I am give the one, see according to my input. If I'm giving, if my switch is off, if my switch is off, then it is 0. My switch is down. Suppose my switch is down, my slide switch will be down, then it is 0. The 0 means, so which one in this case, which one will be selected here? Angle selection. So this line will be selected. Now it is selected the pulse 0. Pulse width will be selected the pulse 0. What is the pulse 0? 50,000. That means 1 millisecond. Of course, the pulse 0 will give the 0 degrees. That means it will select the 50,000 clock cycles. The pulse width will be selected the 50,000 clock cycles. Now the servo motor will be off. Okay, if you can on your switch, according to the angle selection, if you can on your switch, now it will be selected the, see, now it will be selected the angle selection will become 1. This angle selection. Okay, angle selection will become 1. Of course, it selected the 90 degrees. Okay, see here I'm writing. Now I'm erasing here for your understanding. Yeah. So the pulse will take the pulse 90. Pulse 90 means now it will take the 75 degrees, 75,000 clock. I mean 75,000 clock cycles. That means 1.5 millisecond. I mean, of course, 75,000 clock cycles. So if it will count the pulse width will count the, see, this pulse width will count the 50,000 clock cycles, then the angle is 0. If the pulse width will count the 75,000, see, the pulse width was count the 75,000. Yeah. Just a minute. Yeah. If the pulse width will count 75,000, then it is 90 degrees. Okay. So I'm giving here only 2 degrees. Sir, for what is the purpose of this counter, sir? We did not use the counter anywhere here. What purpose of we are using this counter, sir? See, now that will be not ended here. Okay. Just wait. See, coming here. See this one. Our final output is servo out. See, not pulse width is my output. The pulse width is just a register. It will store the angle cycles only. It will store these cycles only. But how it will give the 0 or 1? See, same theory here. Same theory. If my counter is greater than my pulse width, so what is my counter? This PWM period. Okay, so what I'm drawing here is this theory. What I'm drawing here, I will explain. Okay, I will explain. No need to worry about it. So I'm already drawn here. This theory. Yeah, here, this one. So this is that 10 lakh counts. Okay, this 10 lakh counts. So if the 10 lakh, I mean, of course, 10 lakh counts greater than, if the counter greater than pulse width, that means suppose if it is 50. Suppose example we'll take it as, is this true? No, but it will start from the initial counter position. It will start from 0. See, 0, 1, 2 from starting. From starting, I'm taking here. See this one. So it will calculate 0, 1, 2, 3, 4, 5. Some of the time it will reaches the 50. Now that will be ended. Okay, so from this position, 50 clocks, 50,000 clock cycles. Okay, that it will be calculated. It will take, okay, now the time is 1 millisecond. It is for 0 degrees. Now the servo motor will be understand. Okay, if the counter is 50,000, if the counter is 75,000, if the count is 75,000, it will be started from, if the count is 75,000, just a minute. If the counter is 75,000, again it will be starting like this. So again it will be starting from 0, 0, 1, 2. Now it is reaches the 75,000. Now up to here, 75,000 clock cycles. Okay, so the time will be 1.5 milliseconds. Okay, if it reaches the 75,000, of course, now the servo out will become 1. Otherwise, it will be off. This is the counter calculation for the PWM period. See, for this counter 0, 1, 2, 3, up to 1 lakh. Okay, up to 1 lakh. Sir, why this much of time, sir? So up to here, you have to stop the time because of this is the hedges. I mean, we need to calculate that. Okay, because of the servo motor will be work this much of speed. Of course, it will be working with 50 hinges speed. Okay, so that's why we need to take this much of time. So, but we want this 1 millisecond for, of course, 0, and this 75 for this 1.5 milliseconds. See, same this situation was happening here in this code. See, this situation was happening here. See, starting position 1.5 millisecond. Okay, so the counter starts from 0 to, of course, the maximum position. If your maximum pulse width is 50,000, then it will become 0. Otherwise, it will be reaches the servo out 1. Okay. Yeah, I think some members have doubts. Yeah, everyone have any doubt? Anyone have any doubt? Okay. So this is the total information about this servo motor. Okay, and this is, of course, this is the connections. Okay, there is nothing much of connections. Of course, we have to use only 3 wires. One is for PWM, ground, and of course VCC. Okay, and this reset and clock, they are common. Clock and reset are common for everywhere in V and in our programs. Of course, we have to input for the seal. For angle selection, we are using the switch. Okay, for angle selection, I am using the switch. For here, I am selecting the angles. That's it. As per I am using the switch. For sir, what is the purpose of this? Okay, sir, this counter is for this calculation. What is this counter, sir? See, for this counting. Okay, for this overall counting, I am taking here. Okay, I'm taking for overall counting. All of you, I'm taking for that counter for overall counting. This overall counting, I'm taking this counter. And this is for calculating the pulse width. Okay, just so this is the simple code. Okay, the simple code, only 40 lines of code is that. That's it. So this is the information about the servo motor. Okay, all of you, and of course this is the today class, and tomorrow I will show the output as as it is. Tomorrow I will show the output. I will ready for the connections, and tomorrow I will explain the motor drive. See, tomorrow I will explain the LN289. 289 and something. See, tomorrow I will explain this motor drive. How can we handle the DC motor with the FPGA board? Okay, with FPGA board I will show it. How can we handle this DC motor? Okay, so tomorrow, this is the tomorrow class, all of you, and I will send the code also. And this is the connections, and this is the code. I will send the code. Okay. So if you want to change the angle, then you can change it to 180 degrees. So change this clock pulses to 1 lakh. Okay, to 1 lakh. That's it. Everything will be changed here. Okay, you can change here also. The name. That's it. Pulse 180. That's it. And of course, it will be diverted around. Now it will take the. Of course, now it will take the 1 lakh clock pulses. It will be calculated. Counter will be calculated. Of course, the counter will be calculated 180 with 1 lakh clock pulses. That time the servo out will become 1. That's it. Now it will be given the it will give the 180 degrees rotation. That's it. There's no much of logic here. Okay. Yeah. So this is the today class. I think you people are understood. If you have any doubts, you can please ask me.